6(3). So we got f of x equals the square root of x plus 1. Let's see what that would look like. So the square root of x is a sideways parabola. A plus 1 on the x would move it minus 1. So it's going to go through there, through 1, 1, 0, 0, 1. Be like that. So 1, 2, 3, 4. It'll be up 2. And that'll be at 3. And they said from 1 to 4. And we're going to go about the x-axis. So if we're going to go about the x-axis, and we're going to do 6(3's disk method, we're going to have this region down here. And a slice perpendicular to the axis would be in this direction. Spun around, it would end up down here. The thickness of the slice is going to be dx. So we're going to have the integral, a dx, and it's going to be pi r squared. There's no hole in the middle of this, so it's just going to be pi r squared. Pi, the radius is y, but y is the square root of x, plus 1, pi r squared from 1 to 4. Well, that square root squared is just x plus 1. The pi will come out, so we'll have pi, the integral from 1 to 4 of x plus 1 dx. So that's going to be pi x squared over 2 plus x evaluated from 1 to 4. So we're going to have 4 divided by 2. 2 plus 4 is 6. Then put in 1. We're going to get 1/2 plus 1 is 1.5. And we're going to put 4, which is going to give us that, minus that, times pi. 6 minus 1.5 is 4.5 pi. 24. Okay. X equals the square root of sine of y. Sounds worse than it really is. So if it was y equals sine of x, it would be going this way. So x equals sine of y will be going like this. The square root of negatives, when y is negative, are going to be gone. Square root up here, the square root of the y values here will be, this gets up to 1. The square root of 1 is 1. The square root of smaller numbers would be still something in here. And square root of 0 is 0. X equals 0 is the y-axis. This would be pi, because the sine of pi is 0, and the sine of 0 is 0, and it would go out to 1. Even when it's 1, the square root of 1 is still 1, so this will change the curve in there, but it'll still be something like this. And we're spinning it around the y-axis, so we're going to go like this, and y goes from 0 to pi. So we're only doing this part here around the y-axis. So the radius, the slice would be in this direction, perpendicular to the axis, and the radius would be x, and x is this, so when we do pi r, which is x, which is that, squared, it's just going to be the sine of y, square root of sine of y squared is just going to be sine y. The thickness of the slice is dy, and we're integrating from y is going to go from 0 to pi. So we're going to get, let's see, pi, well, as it comes out, the integral of sine is negative cosine of y. Careful you don't put the negative on the cosine here unless you put that in parentheses, or it's going to look like pi minus cosine, and it's really the negative of a negative cosine y times pi. And we're evaluating this from 0 to pi. So when we put in there pi in here, we get cosine of pi, which is negative 1 times the negative pi is just pi. Then when we put 0 in there, cosine of 0 is 1, and we have minus a negative 1 pi, which is plus pi, so this is 2 pi. '29. So region A is up here, and we're supposed to take it about the x-axis. So if A is here and we take it about the x-axis, its image will be down here. Okay, so if that's the image of it, and we're doing 6-3 disk method, we got to slice perpendicular to the axis. The x-axis being perpendicular, that would be this direction. So a slice out here would cause a slice here. This farthest out part would circle clear around down to here with the center at the axis. The inside would circle around the axis here, making a washer. The thickness of the washer is in the x direction, dx, and x is going to integrate from 0 to 2, and it's going to be the big radius, and then both of them are going to be pi r squared, so the big radius is from the x-axis to the top is 6, so it's going to be 6 squared for the big radius. It's always 6. The inside radius, a point on the curve, is x, y, so it's over x and up y, so the inside radius is y, not anything added because it's right off the x-axis. But our thickness was dx, so we want the radius, y, in terms of x, and so that's going to be, and we're subtracting the area of the inside, so it's minus the x squared plus 2. That's the radius of the inside squared. So we got pi large radius squared minus pi small radius, the y, the x squared plus 2, quantity squared. Now to work this out, we've got the pi, we've got 36, we still have to integrate. This multiplied out is going to be x to the 4th plus 4x squared plus 4. That's squaring this quantity. And we've got to subtract it, so it's going to be minus x to the 4th minus 4x squared minus 4 dx That was just multiplying it out. We haven't integrated yet. We have to integrate from 0 to 2. So 36 minus 4 is 32. So now let's go ahead and do the integration now that we've got this simplified in here. So the 32 integrated, it is 32x. Negative x to the fourth integrated is negative x to the fifth over 5. And then we have subtract, and then this integrated would be 4x to the third over 3. Now we've integrated, so now we evaluate from 0 to 2. 0 is not going to do anything, so we're just going to have what we get from the 2, pi times 32 times 2 minus 2 to the fifth is 32 divided by 5 is minus 32 over 5 minus 2 to the third is 8 times 4 is 32 over 3. I'll leave it there. This is just a calculator thing that I think you can do, or we could do get common denominators and figure that out. But I'm going to leave it like that so I don't make any arithmetic errors in the answer. Okay, now in 33 we've got the same graph, but we're supposed to take it about x equal minus 3. So if I go back up here and take this area, A, about x equal minus 3, well, if this is 2, minus 3 is 1, 2, 3. So it's going to be clear over here that we're going to have this shape. And if we're doing this method, our axis of rotation out here at minus 3 is this direction. And if we're spinning this around it, we're going to have a large radius minus an inside radius. The slice would be perpendicular to it. The slice would go this way. And if the axis over here is 3 over, then we're going to have an integral. Thickness of the slice is in dy, because it's up and down. And it's going to be pi in the large radius squared minus the small radius squared. And dy is going to go from, for region A, is going to go from 2 to 6. Now, the large radius, okay, point on the curve is x, y. X is over, so the large radius is going to be 3 plus x squared. That's the large radius squared. The small radius, the inside, the hole in this really large disk, goes up like this. The inside goes up like, comes down over here. The inside radius is always 3. So that's the setup. Pretty straightforward setup. And if we multiply this out, doing some simplification, we're not integrating. Some of you get confused and think you've integrated when you are just simplifying. From 2 to 6, see, that multiplies out to be 9 plus 6x squared plus 6x plus x squared. And then this is minus 9, so the 9's will cancel, and we just have 6x plus x squared. Oop, we're supposed to do this in terms of y, and these are x's. So I don't even want to do this squaring yet. I messed up here. Okay, let's fix this. So we want to do y. The large radius is all the way over to the curve. It's it's x plus 3, but we have to solve for x. And in this equation, x would equal, subtract 2 and take the square root. X would equal the square root of y minus 2. Okay, so redo this. I guess I could still use this, but now I got to put this in for the x. So we're going to have the 2 9s will still cancel. The inside radius 3, there's no problem with that one because there's no x or y in it. So we're going to have 6 times x, and x is the square root of y. So we're going to have 6 square root of y minus 2. X is the square root of y minus 2, I should have said. Plus x squared. Well, x squared is y minus 2. Okay, now we finally got it set up. Okay, to do this integration, this one's easy, this one's easy, this one's a little bit more complicated. There's no minus there. Okay, this one's a little bit more complicated. So let's go through here and do these two first. So we'd have pi, and integral of y is y squared over 2. The integral of minus 2 is minus 2y. Then we've got plus whatever this integral is. Now I'll just kind of step to the side here and do the integral of that. The integral of square root of y minus 2. If I let u be y minus 2, du would be dy, and so this would change to the integral of u, square root of u, du. Well, the integral of that is, so that's u to the 1/2, and so if I add 1, that'd be u to the 3/2 divided by 3/2, so that inverts it. So, and then if I put the y minus 2 in there, I just have 2 parentheses y minus 2 to the 3/2 over 3. 2 y minus 2 to the 3/2, just that, not that 2, over 3. Evaluated from 2 to 6. So I get pi, parenthesis, 36 over 2, which is 18, minus 2 times 6, which is 12, plus 6 minus 2 is 4. Square root of 4 is 2. Cubed is 8. Times 2 is 16 over 3. And that's everything with the 6 in it. Minus, now we got to put 2 in here. So we get 4 over 2, which is 2. Put 2 in here, this, and we get minus 4. And then we put 2 into here. 2 minus 2 is 0, and this will be all 0. So we have pi, 18 minus 12 is 6, plus 5 1/3, And 2 minus 4 is minus 2. Minus 2 is plus 2. So we've got 6, 8 plus 3 is 15 and a third pi. 15 and 1/3 times pi. Hopefully I didn't make any arithmetic errors in there. Almost started to integrate with respect to x, but it's dy. Okay, 39. So we're supposed to take B, this region, about x equal 2. So that's this line. So perpendicular to the axis would be a slice this way. The image would be out here. Slice this way. Well, it's going to be one thing down here, and the outside radius, there is no inside radius. It's 0, so we don't have to worry about subtracting anything. So we're going to have this spun around over to here. It's going to be the same from 0 to 2, but up here, the radius is going to start changing. So we're going to have two integrals. Thickness of the slice is dy, and it's going to be pi from 0 to 2 of r squared, and the r will be consistently 2 on that, squared, pi r squared from 0 to 2, which you'll notice is just the volume of a cylinder, and that's all this bottom piece is just a cylinder with the straight sides. And so we could have said the area is going to be pi r squared times the height, which is 2. Pi r squared times the height dy, but when we integrate that into that, we're going to get the formula, the correct formula. This is just 4 pi integrated is going to put a y on it, and then we're going to put it evaluated from 0 to 2. We're going to put the 2 in here, so we're just going to get pi r squared, 4 pi times the height times 2 minus nothing. So we're going to get 8 pi for the cylinder here. That's the same as the cylinder formula. That's all I'm saying there. But we're going to have to now add to that pi, the integral from, again, the slice will still be dy, but it's going to be pi r squared from 2 to 6. And now r is a little trickier. This is the radius that we want to square, but the point on the curve is x, y, where this is the x and this is the y, so we want to use the x value to describe this radius. Well, that's going to be 2 minus the x. So the radius is going to be 2 minus x, and we're going to square that, but we need dy, so we have to solve for x again, and x would be y minus 2, the square root of y minus 2. So in place of the x, I got to put the square root of y minus 2. Now, it might be easier to square this first and then put that in for the x's. This squared is going to be 4 minus 4x plus x squared. So this part we already know is going to come out to be, when we integrate 4, we get 4y times a pi, and we're going to evaluate that from 0 to 2, and we get 8 pi plus pi integral, so we're going to put the square root of, in for the x, we're going to put the square root of y minus 2 in place of both the x's. And then we're going to have to integrate. So let's simplify that first. So we're going to have 4 minus 4 square root of y minus 2 plus square root of y minus 2 squared is going to be y minus 2. And that's what we got to integrate from 2 to 6 dy. And this 2 can come off of the 4 and leave a 2. And so now we got to integrate, and we're going to get pi 2 integrated is 2y. And as you saw before from the substitution, this is just going to be minus 4 y minus 2, not to the 1/2, but up to the 3/2 divided by 3/2 plus y integrated is y squared over 2. Evaluated from 2 to 6. So we have the 8 pi plus pi times 6 into all this mess is going to be 12. 8 thirds minus 8 thirds times 6 minus 2 is 4. Square root of 4 is 2. Cubed is 8. So we get, when we put 6 in here, we get 8. Plus 36 over 2, which is 18. Minus, now we got to put 2 into all of this. 2 times 2 is 4. This is 8 thirds minus 8 thirds, and the 2 minus 2 is 0, so that's all gone. Minus 0 plus 2 squared is 4 over 2, which is 2. Okay. And so we could work that out. That's a calculator thing. I'll leave that part to you. Hopefully I didn't make any sign errors in that. That's easy to do. 43. So we have y equals 16 minus 2x. So I got to go up to 16 and do a slope of minus 2. So that's going to hit at 8. That's this line. Y equals 6 would be, that's 16, that's 8, so 6 is about here. X equals 0 is about here. And about the x-axis, so that would be this triangle down here. Doing disk method, so we're going to have a hole in it. We're spinning it this way, so a slice would be perpendicular to the axis of rotation, which is the x-axis. So at a point on this curve is x, y, determined by this equation. So our large radius is going to be, and y on this to this curve is from the x-axis, so we don't have to add or subtract anything to it. It's just y. The inside radius is also just y, but it's also always 6. And our slices, our thickness is dx. So we're going to have to write this all in terms of x's. So we're going to do the integral. Slice thickness is dx. So we're going to do pi r squared minus pi r squared. But dx is going to go from 0 to where they intersect. And I think when y is 6, if we subtract 16, that's minus 10 divided by minus 2. X is 5. This point is 5, 6. 5 in here. Just 2 times 5 is 10. 16 minus 10 is 6. So 5 6 is the intersection. So we're going to go from, x is going to go from 0 to 5. Large radius is going to be y from this curve, which is 16 minus 2x pi large radius squared minus the hole in this is going to have a radius of y, but it's always just 6 minus 6 squared. There's the setup. So we have pi. We're not integrating. We're simplifying here first. 16 squared. Let's see, I think that's 256. Minus 32 minus 64x plus 4x squared minus 36. So you take the 36 from 256 and you get what? 220? So that takes care of that, simplifying. And so now we just got an integration. That would be pi 220x minus 32x squared. X squared over 2 reduces that to 64 to 32. And this integrated would be plus 4x to the third over 3. Evaluated from 0 to 5. The 0 is not going to do anything, so we're just going to get 5 put in here times pi. I think you can finish that. 58. Y equals e to the minus x. E to the negative x. That flips it about the y-axis. E normally looks like, e to the x looks like that, going through 1. So the minus x will look like that, where that is 0, 1. And then e to the x looks like this. The negative of that flips it over, so it would look like this. And then if we move it up 1, it's going to look like this. Did I do that right? So we got negative e to the x. Negative on e to the x flips it over. The e to the x looks like this. Oh, I bet that's e to the negative x. Yeah, I think I missed a negative on that. And I don't have the book here, so I'm going to hope that that's what I did, because I don't remember that. E to the negative x is this. Flipped over the negative on it will flip it over the y-axis. That would make it go this way. And then if we raise that up 1, it will go this way. I believe that's what it looks like. So if that's got a negative x, that would look like this. This would look like this. The region trapped by these two would be, and the x equals 0, which is the y-axis, is this little triangle in there. Triangle-ish with curved sides, about y equals 4. So that's y equals 1, 2, 3, 4. So this will have an image clear up here someplace. So this would go up to there. Axis of rotation is here. So we will have a disk, because we're going to slice it perpendicular to the axis. The thickness is dx. And we're going to have to integrate x from 0 to where they intersect. Let's see, if we set those equal, we're going to have e to the negative x equal to 1 minus e to the negative x. If I add e to the x aside, I get 2e to the negative x equals 1. I'll divide by 2, and I get e to the negative x equals 1/2. And to solve for x, we use the natural log or rewrite this, and it becomes negative x equals ln of 1/2. Multiply both sides by -1. That negative would go up as a power, so this just becomes ln 2. You could use negative ln 1/2 if you want, if you don't see that last one there. So x value here is ln of 2. And we don't need the y value. We can put that in. Ln e to the ln 2 is just and a negative, so e to the ln 2 is, well, we can use the negative. The negative of negative 1/2. This would be e to the ln 1/2, which is 1/2. Which makes sense. They meet halfway between 0 and 1. They're the same curve, so it's symmetric that way. All right. So that was just to get our limits. So x is going to go from 0 to ln 2 pi the large radius. The large radius is, we can look at it this way, from there to there, or we can think of it from there to there. It doesn't matter. That's the large radius. The axis is up here at, what was it, 4? So the y value in, let's see, the large one is this curve. The large value, the y in this, if this is a point on the curve xy, y is that height. So the large value is 4 minus this amount. So the large radius is 4 minus 1 minus e to the negative x. And that's got to be squared. That's the large radius squared. Minus the small radius. It's not a lot smaller. It's from here to there. Well, that's y on this curve. So that's e to the negative x. So it's 4 minus e to the negative x is the inside radius. 4 minus e to the negative x. So we definitely want to do some simplification before we actually do this problem. Okay. So we have 4 minus 1 is 3. And then minus a minus is plus e to the negative x that we have to square. Oh, and this is squared. And then this is going to be minus, and we're going to have 4 minus e to the minus x squared. And I haven't done the integral. I'm just simplifying, and I'm just going to continue with the simplification here. So this squared, which is going to be 3 times 3, which is 9, plus 6e to the minus x plus e to the negative x times e to the negative x is going to be e to the negative 2x minus 4 times 4 is 16 minus 8e to the negative x, but minus here, so that makes it plus 8e to the negative x. And then we take negative e to the negative x times negative e to the negative x is plus e to the negative 2x, and the negative of that is negative e to the negative 2x. And we're going to continue simplifying here. So we got 9 minus 16, which is minus 7. We got 6 of these plus 8 of these is plus 14 e to the negative x. And we have these two canceling out. And we're integrating this from 0 to ln2 dx was the thickness. So we got the right variables. So this is going to be pi negative 7x plus 14, and integral of e to the negative x is e to the negative x divided by the derivative of the inside, which is a negative 1, so that's just going to turn that to a negative, evaluated from 0 to ln2, which you can work out. I'll work it out here. It's pi times negative 7 ln2, and then we're going to have minus and e to the minus ln2 is ln 1/2. E to the ln 1/2 is 1/2. Negative 14 times negative 1/2 is negative 7 minus 0. So I'm getting a negative answer. Why am I getting a negative answer? Shouldn't have got a negative answer. That's puzzling to me here. So we got, where did I miss a minus? So the large radius is 4 minus that, which is 3 plus that. Squared is 9, plus 3 of those. Oh, right here. No, wait a minute. No, that would be minus. This is just adding those two together. So that's all right. Let's see here. And this squared would be minus, that would be 16 minus 8e to the negative x plus e to the negative 2x. We've got to subtract that, so it's minus, plus, minus. Those are going to cancel. That's minus 7. Somehow I've got a sign messed up somewhere. Oh, this is time, and this ln2 into here, and ln2 into here is this. That's also times pi, close parenthesis, minus, we got to put 0 in here. Well, 0 into there is 0, but 0 into here is negative 14 e to the 0 is 1, so that's negative 14 pi, and we got to subtract, so that makes plus 14 pi. All right, there we go. I think this will be negative, but this will be positive, and this will be a little bit more positive than that, so that will come out to be a positive answer. There's what I did. I just didn't finish. Forgot to put the 0 in. I was just thinking that's going to be 0, but there it's not. Okay. So negative 7 pi plus 14 pi is 7 pi. 7 pi minus 7 pi times ln2. ln2 is less than 1, so this will be smaller than the 7 pi. We're going to have 7 pi times times 1 minus ln 2. That's it, simplified. Okay, there we finally got that one straightened out. That was bothering me there. All right. Finally, this one. So we're doing the midpoint in our intervals. We're going from 0 to 1. Well, 0 is before this. There's 0.2, 0.4, 0.6, 0.8, and 1.0. This is right in the middle of each of these intervals. And they want us to find the volume about y equals -3. Y equaled -3. So this is some kind of curve. It's up at 8 and 7. So if 8's here, 7's here, so it's a curve that's going up here. And G is down here smaller. And I could spend time graphing that, but it's not really necessary. And if we're spinning it a while round y equal -3, which is down here, then this would have an image way down below. The slices would be perpendicular, but we're going to do chunks now. So we got a chunk that's going to be perpendicular and have a spot down here. So our radius, our slice, would be vertical. Our thickness would be dx. And dx is going to be 2. And our radius, we're going to do is the large radius. So we're going to do pi large radius square. So the large radius is going to be f of x. So it's going to be large radiuses squared are going to be 8 squared plus 7 squared plus 6 squared plus 7 squared plus 8 squared minus the, the large radius is the 8 plus 3 more. So I should have added 3 to each. So it should have been 11 squared plus 10 squared plus 9 squared plus 10 squared plus 11 squared. There's the large radiuses squared minus and times the height of each of these cylinders. Basically, we're getting a cylinder that's 2.2 wide. Oh, this is 0.2 wide all the way around with a height of 0.2 and pi r squared. And we're just using the middle of the disk. So the radius would be 11 squared. Pi r squared times the height. Pi r squared times the height. And so we're doing all the cylinders with the centers in. Now we got to take out the centers. And that's going to be 3 plus how high it is to g of x. So that's going to be 5 squared plus 6.5 squared plus 7 squared plus 6.5 squared plus 5 squared. So we're going to take 0.2 pi times whatever this works out to be and get an answer. That's all they're doing there. Just doing the calculus by left or right hand and actually midpoint approximations. That's all you have to do on that one.